Welcome, everyone. You're here to learn about DraftKings principles for success and DraftKings' journey to modernize their .NET applications at scale. I am Chris Evilsizer, Principal Modernization Specialist for Microsoft Workloads on AWS. I'm joined by Manny, who's our Product Manager for Microsoft Workloads at AWS, and our special guest, Dave Musicant, who is the the Director of Architecture at DraftKings. Senior Director, thank you, I was right. All right, today I'm going to talk about modernization in the real world, how AWS and how AWS team assisted DraftKings in their journey. Dave will be sharing the DraftKings modernization story and provide specific advice on how you modernization efforts. Manny will talk about the tools and resources AWS has to help you in your journey for modernization. Our goal for today's session is to really inspire you to take your modernization journey, your first steps, or to assist you if you're already on your journey. And really big thing I want you to know is that you are not alone. You not have to do this by yourself. AWS has tools and resources and just experience of how to go forward in your modernization journey and accelerate it and make it successful. So there's several reasons you might be here this morning. One is maybe you want to increase your performance, reduce the infrastructure cost by 97%. Well, Dave's going to show how they did that and how they went from, well, I'm not going to take it away from him, but it's really cool, right? How much impact it had by just modernization, not just cost savings, but with performance. Or you might be here because you identified a workload that needs to be modernized. And what do you do now, right? How do you convince other people of your vision? How are you going to do that? So there's two things we can talk about. One is how Dave did it at DraftKings, but also realize that the AWS has tools, resources, and things to support you on how we can convince business leaders that this is the right way to go and how modernization can accelerate your development and save you money. Right? Another thing that comes up a lot is you've been asked to reduce licensing from Microsoft or other proprietary OS workloads. How can you do this? How can you even start going the process? That's something that Dave will talk about, how their successful journey, and that's what we're here to help you with, is how to get off these. So let's talk about how we help DraftKings in our partnership when we work together. So what happened is about 4 years ago, Dave joined the DraftKings team. And at the time, that team was not really utilizing the AWS account team. One of the first things Dave did is came in and talked to his technical account manager and said, look, I need some help with Windows modernization. I want to see what you guys' advice you have. Also need some help with Kubernetes. And so that started the process of deep engagement with the account team. And right here 3 years ago at reInvent, we had our first meeting. We talked about operating .NET workloads in AWS. So from there, Dave had deep sessions on Kubernetes, helped out, and Dave is going to talk about that as well. And then 2 years ago, I think it was, we had a blog post that we wrote, and Dave said, look, we've done this, we've learned these things, we want to share it with the community. And so that's out there. If you look for DraftKings and AWS, you're going to see an excellent article by Dave, and this is a continuation of that. The other thing that Dave has done is, because Dave started this journey, Dave has given feedback to our service team from Manny, and said, look, these are the tools and resources that we wish we would have had. And Manny's going to talk about those today and say, this is what we have available to you. So without further ado, I really want to introduce Dave Musicant, and thank you.
Thanks. Thanks, Chris. First thing I want to start with and sort of clear up for everyone is this is not what I did, this is what we did. This was definitely a massive team effort from everyone. And that's going to be one of the things I talk about, is that's going to be absolutely critical for how you make this transition, whatever it is that you're trying to modernize, work successfully. So as you all know, technology changes is hard, but especially at scale, it's incredibly difficult. When you have a company that moves fast and you've got lots of different teams that are all structured slightly differently and have different roadmaps and deadlines that they have to work with. So it's really easy to make a lot of mistakes, as we did, and hopefully the learnings that we got from those will help you guys avoid the same mistakes. So one of the first things that's really important is figure out your purpose for the modernization. exactly why you're doing this. It's really important because it not only helps you understand where you're heading, but it also helps you understand where you're coming from, what problems you're trying to solve, and it enables you to be more agile as you go along that path so that you can evaluate whether or not you're actually heading in the right direction. So for DraftKings, our why was really centered around some key things. We wanted to really improve our ability to scale our software and to scale our ability to evolve that software and be more resilient, but with decreased operational costs. At the same time, we wanted to make sure that we were keeping up and increasing our developer efficiency, enable them to be able to do more with less. And then you want to think about this as a foundation, something that's cumulative. So whatever you're doing, you want to make sure that you can keep improving and growing on top of that. Your company is going to continually change what it needs to do and how it's doing that. Your organizational structure would change. So you'll want to build a runway for yourselves. And then lastly, for us, we have some regulatory requirements that mean that we have to put certain workloads on-premise. We can't put everything in the cloud. And so we wanted to be able to put something in place that could enable our developers to treat those exactly the same way so that they didn't have to worry about whether or not something was on-premise or in the cloud. They could develop it and deploy it the same way. That why also helps you with the next step, which is getting buy-in. One of the key things here is to know that this is by nature disruptive. When you are changing technologies, when you're changing the way people do things, it carries with it inherent risk, and it can be a bit scary, particularly when you're talking about new complex technologies that no one's ever worked with before. So it's really important that you understand how to make a clear message to help sell that through to people so they can understand not just what's asked of them, but also the benefits that they and the company get out of that. So internally at DraftKings, we created an internal brand called Spark, which Chris was alluding to. And it really helped change the conversation. Instead of one where people were like, ooh, this Kubernetes, it's really complex, like horizontal pod autoscaling, what is that? It changed the conversation to being like, Spark, how do we get on that? It's about sparking innovation, resilience, stability. And like, we want all of those things. That's great. And then you want to utilize your organizational structure, right? It's not just about saying like, hey, engineers, we got to get them to want to do this, to be excited about this technology. Those engineers are working on certain products or different types of your business domains where they have roadmaps, they have deadlines, they have things that they have to do day to day. And you're going to be asking them to take some time out to do this. That's not just on them. That's on the leadership as well. And it's important that you get that alignment such that you can get that space and room within everyone's roadmaps to work together towards a solution. And along with that, you want to make sure that this is something that's understandable, manageable, and something that people can take on. So it's really important to break it down into different phases. Phases that will still give you positive benefits, and I'll talk about how we did that ourselves and the outcomes and benefits we got from each phase along the way. But for example, if you were trying to go from Windows Framework to .NET Core on Kubernetes, you might break it down like we did into a few phases of going first to .NET Core, and I'll talk about the cool benefits we got with async all the way there. Then going from Windows to Linux, and some of the benefits we got there in scaling and cost. And then finally to Kubernetes. And that's both technologically, it's fewer moving parts, right, which everyone knows from developing, you're always going to be more likely to get success. But it's also that you're thinking about the way people do things and the amount of shifts that they have to do in their jobs, in the processes, and the way they approach these things. And then within those phases, you want to be very intentional and targeted with how you approach this. What you don't want to do is just go right in and say, hey, we're going to build some automation to convert everything. That works if you have, say, 2 microservices. It works if you have a toy application. But in the real world, in an enterprise organization, that doesn't work. Teams work very differently from each other. Not everyone's microservices are exactly the same way. They use different third-party libraries. They have different access patterns or different data structures that they're working on top of. So there's going to be major differences between those. So you want to start with a few key teams, pilot with them, really prove out and understand the general commonalities across those. From there, you can build something like a runbook that you can give to a number of teams that they can start doing those themselves, and you'll crowdsource the feedback from them. And from that, you can finally build some automation. And I'll walk through exactly how we did that and the benefits that we got from that. And along with this, remember I talked about that why? One of the key things in using that why is data collection. You want to be data-driven. The data will help you from a number of areas, one of which is understanding what your problems are today and being able to measure those. So you may say, hey, maybe we have too many rollbacks. Maybe our incidents are too high, or it takes too long to support and maintain these things. You want to collect a lot of data on that, and that not only helps you understand when you've successfully fixed those things, but also along the way, maybe you're heading in the wrong path. Maybe your solutions aren't the right way to solve those. You can make adjustments because you're collecting that data. But I'll also talk about another really cool thing about data. So we had some misconceptions about things, and we had some ideas on how to approach some of this stuff that the data told us we were wrong on. And that enabled us to make those changes and then fill those gaps. And then remember that whether or not you have an officially defined SDLC, all of your engineering teams have an SDLC. They have a way that they get from ideation to their software running in production and maintaining that. And that is a habit that they've built to be able to do their job successfully. It's something they're comfortable with. And as I mentioned before, change is disruptive. It's scary to people. And it also means that they have to think about how this is going to change things they've built to help them do their job successfully. So you really have to think about how you train those engineers and those teams to become comfortable with the new way of working and the new technologies that they're working with. And some of the key principles there are that we learn by struggle. So it's not enough to just put together a manual or documentation and say, hey, go read this. This is how you do it. People are not going to remember that. They're not going to internalize a lot of it. And when you onboard new people and other people leave, a lot of that knowledge is lost because it doesn't have enough of the why, and it doesn't work to the way they work. And that's the second piece, is people tend to have a lot of trouble taking something they've learned and applying it to a completely different scenario. So when you do your training, you want to make sure that it's built to the way that they work, the way that they do their jobs. And you've got to make sure that this is scalable. No matter how big your team is that's in charge of this modernization, you can't have them spending all their time running everyone through workshops. And every time someone gets brought in new to the company and onboarded, they have to go and give them workshops. So you need this to be something that's scalable and self-service. And I'll talk about how we did that. So for DraftKings, we broke this down into a few different phases, really making sure that they were foundational, things that built on top of each other, and as I mentioned before, give us that runway. So we started with .NET Framework to .NET Core, and I'll talk about the cool benefits we got from async all the way. Then we went from Windows to Linux, and I'll talk about some of the really cool cost benefits and scaling benefits we got there. And then this is where we went to that really strong foundation, really changing the way we worked, moving to Kubernetes, EKS in the cloud, and Rancher Kubernetes in on-premise. And then from there, we're able to really do a lot of interesting things on top of that foundation. So I'll talk about what we did in scaling and deployment, and then that super-powered future that we're working in today. So moving from framework to core, the first thing you'll notice here is exactly what I talked about before. It's that really intentional, targeted way of approaching this. And I know a lot of people might think, well, this is overkill. You can just convert that microservice quite easily. And the thing is, you can. But what we're not trying to do is make a microservice work on your laptop. It needs to be productionalized. There's a lot of things that go into that in terms of stability, resilience, observability, monitoring. So we did a lot of work to figure out how we could manage all of the custom things that had been built over the years in DraftKings for our microservices, come up with solutions to make those easier for developers to work around, third-party libraries, et cetera. Then we piloted with a couple teams. It took us a few weeks to get those working. Again, not running on their laptops, but to get them productionalized. And then from there, we were able to produce a runbook that people could consistently use to convert their microservices. And we use that to crowdsource. So we use that in a couple ways. One is we set up a support channel, and everyone who had done a conversion, they became deputized. And they actually were helping us help other people do these conversions and capture data from them. And then from there, we were able to build automation. And the automation would convert your microservice in just about a minute. And then it took, on average, about 20 total minutes for people to work through all the minute differences of their microservices. If you remember, the data collection, so we built data collection into our CD pipeline. So we were able to not only see what things were being converted over to .NET Core in production, but we were able to actually tie it to teams. And this became a great motivator for teams. so that they could see not only how they're doing internally, but they could compare themselves to other teams and sort of compete against each other to see who could get converted the fastest. And things don't always go perfectly in the real world. So testing is incredibly important. And you'll see a number of cases of that with us where we discovered things later on in this talk. So we put a lot of time and effort into making sure that we had good automated testing and load testing capabilities for our engineers, and that we had guidance for them on how to do that to specifically make sure that when they did this conversion, their microservices would work properly. And then we set up dashboards for them so that they could do canary deploys. So they could say, hey, we're going to send 25% of the traffic to these new instances, and they would have easy monitoring for them to see, does it have the right latency, throughput, does it have too many errors? And they could make sure that they had minimal impact on the customer and the product. Some key things, as I mentioned, with async all the way. Number one is that it's for things that are I/O bound. So you can think of like REST calls coming into sockets. You can think about trying to hit databases. Previously with .NET Framework, those were blocking calls. So it was meant that if you really wanted to get very high throughput, you had to do not only a lot of pretty interesting things with thread pools, but you also usually had to do a lot more cores. So that's parallelism, having a lot of cores to run your workloads in parallel to each other. But Microsoft did an absolutely amazing job with async all the way. And they created something called the synchronization context, where they can use a single core to run many, many workloads in a concurrent manner. But that comes with a few caveats that you need to keep in mind. One is that it does, by nature, add a little bit of overhead to it. So you've got to be very careful about what types of things you're changing over to this and accounting for that. The second thing is you can't use things like out parameters anymore. That's because it would need to marshal the synchronization context into the response in order to make sure that that works properly. So instead, they recommend that you use tuples. And then you've got to also think about whatever you did as an organization to make sure that your previously blocking synchronization code worked properly is no longer in there. So we had a lot of things around concurrency limiters, for example. They served us very well in protecting our thread pools previously, but once we went to async all the way, they actually harmed us. So I'm sure you can see here, if you look at the top graph, exactly where it went async all the way. We got some massive, massive benefits in terms of latency. But as I mentioned, things don't always go perfectly in the real world. So back when we did this, there actually turned out to be a bug where it would pull in the wrong version of Kestrel, and that would then use the wrong socket library as a result. And so we got very unstable and poor performance on a number of our microservices. But because we did really good testing and we had good observability in there, as a result, we were able to discover this, quickly diagnose it, and get that fixed. And if you look at the lower right, you'll see that we had nice, consistent, high performance from our microservices. So what you're looking at here is actual real numbers from production of one of the microservices we converted. On the left is before we went to async all the way in .NET Core, and on the right is afterwards. And what you'll notice is the number of instances we need to handle the same throughput is 1/10 what it was before. But actually, it's even less than that. If you look at the memory, you'll notice before we were using 8 gigabytes of memory per instance. Now we only need about 200 megabytes. And CPU, we use 1/10 the amount that we needed to use before. It's really pretty an amazing benefit of async all the way. So moving from there, we decided we were going to go to Linux as our next piece. This was a stepping stone on the way to going to containers. And here's where we made a miscalculation. We thought this was going to be nice and simple and easy, just a few quick changes. But most of the changes we figured were really contained within the microservice. But it wasn't. It turns out that the OS is baked into almost everything across the board. So along the environment state. So most of our developers were on Windows laptops. And those, most of them ran pretty well, but sometimes they would get differences because now their stuff was running in production or on test environments in Linux, but on their laptops it was Windows. And so they would have things that would run into issues. CI, we previously used Windows agents. Now we needed to switch to Linux agents. And then things like test environments. So we had some automation that would spin up instances for people, but because they were Windows, we had a lot of Windows-specific code to do that. We had to migrate that And then provisioning, our Terraform had a lot of things baked into it. In addition, within the microservice, the obvious one, casing. In Windows, it doesn't matter if you use uppercase or lowercase, but in Linux, that's a different file. It's a different actual property. It won't recognize that. As well, things like configuration, logging, and metrics, we had a lot of things built in for that. And encryption. We were using Windows APIs to do encryption and PCI filtering on our instances. Even with the OS change not being immensely massive, it still was a change for developers, a change in the way they worked. So we did a lot of work to create training and guidance for them, but also to make that crowdsourced. So we made sure that, like I said, we were deputizing people. A lot of people were contributing back their ideas and the things they had learned from doing this, either at this company during this transition or at previous jobs that they had. And that really helped us build a lot of great guidance for a lot of different engineers, rather than just having, say, a small team of 5 or 10 people doing that for everyone. Some of the massive benefits we got here were around scaling. So back then, it took about 20 minutes for our Windows instances to spin up. With Linux, we were able to get that to under 2 minutes. So a really massive benefit for us there. In addition, cost was a huge savings. So AWS will actually give you a big cost benefit to going to Linux instead of Windows EC2 instances. For us, across all our instance types, that averaged out to about 40%. But even on-premise, we got a savings. Because on-premise, we had to purchase Windows licenses, and now we no longer did. And then also effort. So our SRE had to spend a lot of time and effort to install, support, maintain, manage those Windows instances on-premise. And when we moved to Linux, we saved them a lot of time. And for developers, we were able to give them more efficiency and consistency. So we now ran these things locally in containers, and they didn't have to do any work to make sure that that worked. It would just spin up from the IDE. But it also meant that it now ran the same way on CI that it did on their laptops, because we could control what was inside of that container. And then the CI as well was much more stable, because now we had everything isolated in containers. And that prepared them for the next phase, which was moving to Kubernetes. So as I mentioned, Kubernetes is a big, scary thing to a lot of people. But more importantly than that, it's a mindset shift. So if you think about the old world, you're really defining a static view of the world where you say, hey, I'm going to deploy out 3 instances of this thing on a C5.2x large. It'll have this amount of RAM, this amount of CPU. And then you have things like monitors and alerts and whatever to deal with when you need to make changes, or you write some stuff to help you with scaling. Kubernetes is very different in that you don't tell Kubernetes the static things that you want put out there. You tell it what good looks like, what bad looks like, and you tell it what the state of the world should be. And then Kubernetes says, OK, great. Given all of the things that you've told me on how I should handle that, I'll take care of it and I'll handle it. But that's a big, massive shift for how engineers have to manage this stuff and think about all of this. So we knew that it was going to be something really important we had to train our engineers to get comfortable with so that they could do this successfully. So we created what we call reference workshops. And this workshop, for example, one of them, built to their actual workflow. They start with scaffolding to create a microservice locally, but it has problems. So none of the tests pass. And the engineer has to work through getting all of those tests to pass. Once they do that, they push it up to CI. But we actually have a problem in CI, so they have to fix the problem in CI as well to get that working. And then they use deployment to push it out to a workshop cluster. And in the workshop cluster, we cause all sorts of problems. Nothing comes up. The database is unreachable. It's under-provisioned. It gets into a restart loop. All things that they're probably going to have to deal with in the real world with real production microservices. And this causes both that struggle, where they have problems that they have to try and figure out and tools they have to learn how to use so they remember it. But it also is built to their workflow. So it's something that once they do this successfully, they will be more successful in their jobs. And it's scalable. This was all self-service. So we did not have to have a team that ran them through this workshop. And if you remember that data, we actually could capture data on this. So we knew whether or not engineers went through these workshops and if they completed them successfully, which gave us one of our first big insights. So I don't know how many of you have done things like this where you've converted something and you thought, you know what, we'll put our junior engineers on it because it's not really that critical. It's something they can do pretty easily. That's definitely a take a lot of people have, and we had that as well. But that actually can come with a lot of problems. So a very junior engineer is typically pretty new to the company as well. They're missing a lot of that domain knowledge. They're missing a lot of the knowledge and skills around the why behind a lot of changes and things that were done in the code. And so they ran into problems. But what we discovered was we could fill that gap with this workshop. And we found that the engineers who had gone through this workshop took 40% less time to successfully convert a service to Kubernetes than an engineer of the same level and tenure who had not done the workshop. We also got great feedback from people saying that this was a reference for them, that this was something that they refer back to all the time to do their jobs, not just to do the workshop. Another area that was really important to us was not just training engineers to work in this new way, but to make sure that we weren't adding a lot of extra tasks and skills that they had to learn and do to be successful at using this new approach. So I'll talk in a little bit about how we use some technologies like Helm and MS build changes and GitOps. Also things around, as I mentioned before, that commonality. We have on-premise data centers and we have the cloud. So I'll talk about some of the things we did there to make it so that they could deal with them exactly the same in both environments. And then by moving to something standardized with this path, we were able to use a lot of third-party tools, open source tools that made things really easy, like in observability, things that were basically no effort for us to get them working out of the box. And then something really cool also with that standardization is we were able to empower engineers to do things that they couldn't do before. So, for example, with us, we're a SOX-compliant company, and I'll talk a little bit about one of the things we were able to do there to enable engineers. So the first thing we did was work on how our microservices were built. We previously used a technology called Cake. I know a lot of people have used this. Cake works generally well, but there are some problems with it. One is it does tend to be very complex and the documentation's not great. Engineers had a lot of trouble really understanding it. It's also hard to really well package it up with good defaults for each other and enable them to cleanly and easily override things where they need to. So what ended up happening was everyone's Cake files were slightly different. And when we needed to push out some change across the entire organization, we couldn't. We had to get everyone to manually change all of their Cake files because they were all slightly different from each other. In addition, probably one of the biggest problems is that Cake didn't always work the same way on people's laptops as it did on CI. And as a result, not only did they have differences, but it was incredibly hard to troubleshoot because they can't reproduce it on their laptops. So moving to MS Build, we were able to do a couple things. One is it was consistent. It worked the same everywhere. It was also something that was nice, simple, and easy and understandable to the engineers. They just pull in a package, and then they can configure it right through their CS proj. And it enabled them to do things like control what they were publishing in their artifacts, their container images. They could do versioning, Git tagging. They could also set up code coverage and automatic reporting of their test results. And the other cool thing here is, as I mentioned, we stuck to standards. So we didn't have to write a whole lot of documentation for this. Microsoft already wrote it. So we just used their documentation. The next area was Helm charts. So when you move to Kubernetes, the configuration uses something called YAMLs, which is a good format, and it's generally pretty easy for people to understand. But there are some drawbacks. One of the ones is similar to Cake. You get a lot of different YAML files. People are copying and pasting them, and then they modify them slightly. So you have the same problem of trying to roll out changes across the board. Another thing is it doesn't have things like type checking built into it. You can't do things like unit testing. So with Helm, what's great is you can package these up and templatize them. So you can put in good, sensible defaults, but allow people to override them. It also has schemas. So we could do type checking, not just whether or not something was an integer or a string. It even lets you do things around specific formats of that. So people were less likely to accidentally make mistakes in their configuration. But even better than that is the unit testing. I don't know how many of you have ever set some properties for configuring your microservice, and it came out with different configuration than you thought it was going to. Something unexpected happened. With unit testing, we can prevent that problem. So we actually built this unit testing. It's in our pipeline now. We built it into our pipeline so that people can actually get repeatable configuration that will do exactly what they think it will do. Another key thing when you move to containers is that they work very differently than EC2 instances did with, say, VMs. And that's that they're immutable. You're not supposed to be changing them live. So previously, our SRE used a technology called Chef. And they use that to, in production, do things like security patches, for example. And it was great. They were able to keep things up to date. But it was definitely a lot of effort on their part. And it does come with a lot of risks as well. When we went to containers, we needed to make sure we were still doing the same thing, that these were secure and up to date. So we built a pipeline that actually scans for things like CVEs and does some other checks. And then they get stamped as golden images such that they can be used in deployment. Another key benefit of going to this standardization and this foundation that we built on top of Kubernetes is things like Open Policy Agent. So as I mentioned, we're a SOX-regulated organization. So from a very simple standpoint, you can kind of think of that as you need to be very careful about any changes you make that could cause financial harm to the customer or the organization. So that meant we had things like we couldn't allow certain services to be scaled by engineers because they could inadvertently bring that whole system down and cause some financial harm. That meant they had to file tickets and wait for someone else to have time to scale that for them. But with Kubernetes and Open Policy Agent, we're actually able to set specific gates. So we can set rules for a different microservice. And let's say we've done that testing. We understand what the minimum amount that thing can work properly at. We can set rules that won't let them scale it below that. And now we can enable those engineers to scale, and we don't have to worry about the compliance problems because it's built into the system. From there, as I mentioned, we started working on some really cool things. So I'm sure a lot of you guys have an organization that's got things done many different ways, right? Maybe it was mergers and acquisitions. Maybe it was some legacy code. Maybe it was just every team was empowered to do things slightly differently. So you may have things like secrets that are in different source providers. For example, Vault and AWS Secrets Manager. And typically what that means is you have to write some code or put something in place to make sure that it can pull it from the proper provider, however it needs to get those secrets. That's tough, especially when you have microservices on multiple different languages and runtimes. You've got to support that across all of them. And it means you have to worry about any changes across each of those. So there's a really cool technology that we found called external secrets. And what this does is pretty cool. So you can actually mount IAM roles into your pods with each of your instances. And then external secrets will actually use that IAM role to go and request secrets. So it can only request the secrets that service has access to. So it acts just like any other IAM service. In addition to that, it abstracts it fully away from the microservice. So you can have multiple providers behind it, and the microservice doesn't have to know anything about it. They get mounted to the pod as Kubernetes secrets. So every single microservice pulls it the same exact way. And it enables us to do hot reloading. So in AWS Secrets Manager, for example, we have secret rotation. And if you're using in .NET Core, iOptions Monitor, that will automatically pick up the new secrets. The next big benefit that we were able to get off of this was with HPA, so horizontal pod autoscaling. If you remember what I talked about, that mindset shift, the way Kubernetes thinks about the world, it's that good and bad behavior. So what you can now do is you can define for it what good and bad behavior looks like for your services and how to handle when something's getting into either state. So you do that with things like metrics. So for example, you can say, hey, when this thing hits 80% CPU, that's bad. That's getting into a bad state. And you can define for it how you want it to get out of that state. Or if something's caught in a restart loop or it's not responding, you can define metrics around that. And then Kubernetes, without any human intervention, will take care of that and get you back into a good state. Whereas previously, you'd probably have to set a bunch of monitors and alerts. When it starts getting a little bit hot, an engineer on call gets a call, they go online, they take a look at it, they diagnose it, and they spend a lot of time getting that thing done properly. Now Kubernetes will take care of that for you. But there are some caveats here. Number one is if you use an external metrics provider, if that does become unreachable, that will affect Kubernetes' ability to properly scale your service. So you need to be very careful about that. Make sure you have fallbacks for it. The second thing is make sure you're choosing metrics that fit your workload. So if you have something that's not CPU intensive, don't use CPU as a metric. And then the third one is HPA can't solve all scaling situations. So for example, for us, during an NFL game, someone fumbles the football, it gets returned for a touchdown, we'll get a massive instant spike. And it's too fast for HPA, because it can only scale as fast as your services can scale, get ready, and be put into the load balancer. So typically, you'll want to combine this with some other solutions. For us, we use scheduled scaling, where we'll bump up that minimum amount to make sure that we can handle any unforeseen spikes like that. Some of the cool benefits and outcomes we got from this. So again, this is real-world numbers, so that's why the requests don't match up exactly, but they're pretty close. What you'll notice is before, we had to pin it at 100 instances. That was the only way we were able to consistently get good behavior in handling this traffic with all of the access patterns that we had. On the right, you'll notice something pretty interesting. It's not a single number anymore. And that's because the team did a lot of great load testing to make sure that they understood for typical traffic, this needed to be 3 instances. It was very good at running that comfortably. But they also defined how Kubernetes can handle any changes in that traffic. And so for this time period, it actually ended up scaling to a max of 12. And it only did that when it needed it, and then you can see it actually spun back down when it didn't need it. So you're really saving yourself a lot of costs on that hardware and time for people to manage this. Another interesting thing, remember I talked about that foundation, that cumulativeness? So this is also using async all the way. So you can see we got a lot of benefits and improvements in our latencies, despite the fact that we're running a tenth or fewer the number of instances. And of course, we got much more stable and predictable CPU, but there's still stuff for us to learn. We're still getting comfortable with this. So the team that did this, they probably have their CPU too low, but that's OK. They're still getting comfortable with it, and they'll make those adjustments over time. And then the same thing with memory. We're using significantly less memory. It works well, it runs well, but there's probably still some cost savings that we've left on the table there by going a little bit too low. From there, we're really moving into some really cool things we can do to help our engineers have much, much better output. So one of the coolest things that we worked on was isolated testing. Awesome, we actually have John here in the audience who worked on this project. He's done some amazing work with this. And isolated testing really enabled us to do some pretty cool things. So one of the great benefits of this, imagine you have a microservice and you have multiple engineers who want to work on it at the same time and run some tests. If you have just a single test environment, they've got to schedule it with each other to make sure they don't step on each other's toes. Here, they can each run it at exactly the same time. And it's repeatable data. Every time they spin that down and spin it back up, it starts up clean exactly the same way it was before. You go and change a whole bunch of data, it's back to the way it was before. And it's not just from 2 people working on the same microservice. It's also people who are running on microservices that have the same dependencies as well. We can make it so that they don't get in each other's way and that it's stable, consistent, and repeatable. It also means we can do things and have done bringing in chaos testing and stress testing. So you can cause all sorts of problems that mirror what you'd see in production. Maybe network problems, latencies, dependencies are down. You can cause all sorts of problems that get the environment into a very bad state. You don't get in anyone else's way. You can shut it down, spin it back up, and it's as if none of the chaos ever occurred. And we also have the ability to make these live targeted environments. So if you have quality engineers who want to be able to test against some of these microservices over and over again, they can spin one of these up. Or a front-end engineer can spin these up and actually hit it from their application. And as I mentioned, there's a lot of cool things you can do in here. So we actually have the ability, we run local stack in these test environments. So you can even test your AWS resources without causing any problems or cost on any of that. So you can test things like SQS or Lambdas right in there. And also we have the ability to mock microservices. So you can determine, hey, you know what? I don't want to spin up this whole other dependency. I want to just mock it because I know the different types of responses I want. And there's conditions you can put around that. Or you can run both mocks and real versions of the services. And this is a real environment. So you can even test things like HPA and scaling. As you hit it with more load, you can test, is it actually responding properly? And then it can run automated testing and produce reports for you. So the next big benefit that we've gotten from this, I'm sure all of you have seen this, there's lots of reasons why you might be in multiple different environments, multiple clouds. For us, as I mentioned, we have the regulatory requirement where some things have to be on-premise, some things are in the cloud, so we can't just build a pure AWS solution. But there's also things like mergers and acquisitions. It may be that you have multiple clouds, but you want AWS to be your hub, and you want your engineers to be able to deal with everything in exactly the same way. So for us, that foundation really enabled us to do that. So if you remember on-premise, we can now use IAM roles on-premise as well. We don't have to do anything special to get them to be able to safely call and securely call our AWS resources. So external secrets enables us to do that, along with some OIDC. In addition to that, we have another cloud where we're able to map from the identities in that cloud's version of Kubernetes to IAM, so that that other cloud environment, all those microservices, they don't even have to know they're in another environment. They can call SQS, they can call another microservice, or be called by another microservice, no problem. And so that's really one of the key things here is figure out your why, and then make that build you a foundation where you're continually giving yourself more capabilities over time for things you couldn't even have thought of at the beginning. So with that, I'll turn it over to Manny.
Oh. Thank you. Well, quite insightful. Thank you very much for sharing your wisdom with us, Dave. So with that, let's switch gears and talk about how AWS can help you in this regard. As Dave mentioned, his team actually went through a lot of experimentations. They went through a lot of learnings from this, and then they went through this modernization journey. We've taken learnings from customers such as DraftKings, and from an AWS perspective, we provide you with the right templates, the right prescriptive guidance to help you go through this journey. This includes AWS training and certification that we can actually do. We have our solution architects and experts that are available to look at your application and give you prescriptive guidance in terms of how to actually do the transition to the modernized world, as well as we also have AWS investments and programs that are available for you that you can avail that can help you offset some of the cost as you go through your modernization journey. So Chris and I will be here after this session, and we'll be happy to answer any question regarding programs. Now, switching gears and talking about modernization tools, Dave actually talked about all the things that they have actually custom built. So we've actually taken a lot of learning from DraftKings and customers such as DraftKings, and we've actually built products that can help you speed up this journey. So let me walk you through at a high level what we've actually done. So when customers start their modernization journey, they typically start with assessment. And when they start with assessment, they think about, okay, I'm going to look at my application inventory. I want to find out which applications are there and what is the modernization pathway. To help customers with the assessment, we launched a product called Strategy Recommendations under Migrations Hub. And what it essentially does is it looks at your application inventory, and then it gives you, it understands what those applications are, and it provides you the right modernization pathway. For example, you may want to refactor your application, move it from .NET Framework to .NET Core, and then deploy it on EKS, for instance. Or the modernization pathway could be, you may want to re-platform your applications to run on Windows containers and deploy them, and so on and so forth. So to help with assessment, you can use product like Strategy Recommendation. Now, when you go through the modernization journey, there are typically multiple pathways that customers go through. And Dave was talking about the refactoring pathway here, where customers want to move from framework to core. To help facilitate that, we have a product called Porting Assistant for .NET. It's basically an analysis tool that looks at your .NET Framework applications, and then it understands it, and it provides you a pathway to move from .NET Framework to .NET Core. It identifies the incompatibilities that are there, the right libraries that you need to actually switch to move to .NET Core, and it is basically an assistive tool that can help you transition or speed up your transition from .NET Framework to .NET Core. Now, in some cases, customers might still want to run their applications, for example, on containers and Windows containers, for example. And there are many good use cases why you may want to run it on Windows containers. So to help such customers, we have a product called AWS App to Container. And what it does is that it takes your applications, your runtime applications, it scans it, and it helps you transition your application to run on ECS or EKS. So it actually takes it, it creates the right container images, it creates the right deployment artifacts, and then it will also help you deploy those applications to EKS or ECS or App Runner. Another common pathway that customers look at is they take their monolith application and they want to actually break it into microservices. And then they want to do, for example, a strangler fig port-in. So we have a product called Microservices Extractor for .NET, and what it does is it scans your .NET applications, and it provides you a visual representation of how your application is constructed, all the namespaces, the classes, the methods, and the interdependencies between them. And what it will help you is to say, OK, this is how you can break your monolith to microservices. And once you confirm that this is the pathway that you want to move, you can actually simply right-click and say extract to microservice, and Microservice Extractor will actually do the work for you, and then it will actually create a new solution. So what it aids you to do is it can help you simplify the process of taking your application and breaking into smaller pieces, and it will help you do the transition at a faster clip. Last but not the least, we also have AWS Toolkit for .NET Refactoring, which is basically a Visual Studio plugin. And what it will help you to do is to take your applications that are running, again, on Framework, and it can help you transition to core. It not only does that, but it also helps you do test deployments as well. So for example, you want to understand, OK, I've actually moved it, and now I want to actually test deploy it on ECS, for example. It will allow you to do it. So in summary, I mean, we are happy to answer more questions. We'll be here after the session. But in summary, what I want to communicate here is that AWS has got the right tools for you, the right programs for you, and the right incentives that can help you speed up your transformation journey as you move and transform your applications to more modern and open source and cloud-native services. So with that, we can open it up for questions.
All right, yep. Thank you, everyone, for coming.